Okay, enough about the scheduling based MAC protocol. Now I will start the cognitive MAC protocols. Only 2 or 3 slides are remaining. 3 slides only. Yeah. Okay. So what are the cognitive MAC protocols? I already told you cognitive MAC protocols help us to access the bands of other channels. Access the channels of other bands. Okay, what it is? Okay, an essential factor of wireless technology is spectrum scarcity, which is due to the inefficient spectrum allocation and utilization rather than unavailability. Okay, what do you mean by it? Inefficient spectrum allocation is the bigger issue than the spectrum scarcity. Okay, spectrum is, we have sufficient spectrum, maybe less, but we are not still utilizing all the spectrum efficiently. So we should first focus on the spectrum utilization. Okay, so cognitive radio helps in that, means using the spectrum, means reducing the spectrum scarcity by efficiently utilizing the channels, okay, of other bands. Suppose one channel is free of other, suppose for example you can say the FM is switched off after 12 in the night. So what we can do, we can use that particular band until the morning when it is restarted. So for that 4 to 5 hours we can use the FM bands to transmit other types of messages. Okay, so we can do that. So that will avoid the, means that will improve the channel utilization. Okay, so we can do that. So cognitive radio do the same thing. So what is a cognitive radio? Cognitive radio uses a software defined radio. What is a software defined radio? We can change the parameter of transceiver with a software only. Means suppose on which channel it should tune or on which channel it should transmit or receive, we can do it using software. That is what software defined radio is. Okay, we have some other applications, some other features in that also, but we do not work on the SDR in when we talk about MAC in VANET. We just say that we have one node that enables the cognitive channel selection, and it has with the help of SDR, but we don't actually use it because SDR is a bit of physical layer part. Okay, in simulation when we do experimental work, then we will have to use SDR, otherwise we just assume it that our node has, and there is a code for it. So okay, so cognitive radio is what? We use the different channels of separate bands. Okay, so what it does, it senses the current spectral environment. Okay, sense the current spectral environment means it can sense the channels, okay, of other bands as well, whether they are free or not, learn about the present as well as memorize information about previous data transmissions, receptions together with their power and bandwidth. Okay, merge the currently acquired knowledge together with the past history and exploit them in devising a given objective, such as increase the network's capacity, mitigate interference, etc. Okay, these two lines means a lot, and where these two lines indicate in any area of research, whenever you have some historical data, okay, here like past history, okay, knowledge of past history and memorize the information about previous data transmission receptions. Whenever you see this type of thing, means previous data, so you should be extremely happy in that case. Why? Because in that case a vast area opens for your research, and that area is of machine learning. Okay, and for your information, that area is not very tough. Why not very tough? Because we are not here to design algorithms of machine learning. We are here to use them only in our scenario or in our networks. So that is why those are very easy to implement. So you can use those things. How you can actually proceed towards those, I will tell you from tomorrow onwards. Don't worry about that.